Hello and welcome to our video on finding the area under a curve. Now this is going to be an introduction. We'll have some more examples later. So we have this shaded region right here, and my goal is to find the area of this shaded region. So here's my graph and my goal, which is to use rectangles to approximate the overall area. So how are we going to do that? You can see that we have this interval from 0 all the way to 2. And what I'm going to do is I'm going to use 3 rectangles to approximate this area. Now if I'm going to use 3 rectangles, I'm going to take my interval from 0 to 2 and I'm going to break it up into 3 pieces so that you can see here's my first piece, second, and finally third. Now what I'm going to do is I'm going to follow this line up, and I'm going to draw a line across, and I'm going to form a rectangle. Now I have 3 rectangles here. Oh, by the way, this was the function, x squared plus 1. That's this parabola right here. I have 3 rectangles, and all I got to do is figure out the area of each rectangle, because finding the area of rectangles is quite easy. It's just going to be the length times the width, and I'm just going to add those up. And in this particular example, if you were to add them up, we would get 6.1481. So if I wanted to approximate the area, I would say it's about 6.1481. Now the problem is you can see in each one of these rectangles it's a little bit of an overestimate. Alright, my true area is down here, so I'm adding a little bit more than I want. So let's go ahead and take a look at 4 rectangles. You can see the area that's an overestimate. It actually got a little bit smaller, which is very good. So if I were to do more rectangles, I would get even a better area. So let's take a look at 8 rectangles. Again, you can tell the area here getting smaller and smaller. Now I'm going to have to calculate the area of 8 rectangles, but the area that I get is going to be better. Notice that it's 5.18. It's down 1, because I think with 3 rectangles we were at 6.18. So it's going down a little bit, and that's because it's cutting off a lot of that overestimate that we have. So let's take a look at 24 rectangles. You can see the overestimates are even getting smaller. So that means the area of all these rectangles is actually becoming an even better estimate of the area under my curve. So now I have, well, I guess what's the point? The point is the more rectangles we have, the better the estimate. So I have 60 rectangles right here, and you can see that the overestimate for these is extremely small. So if I were to add up the area of 60 rectangles, which is 4.7337, it should be a pretty good estimate. In fact, the true area of this under the curve is 4.6666 and so on, so it's not that bad. So let's go back to the example where we had 4 rectangles. And I actually want to go through, compute the area of the rectangles, and then that will give me my estimate. So the formula for the area of the ith rectangle, like the first rectangle or the second and so on, is this formula here. Now the I just stands for whichever rectangle you're on. Delta x stands for the width of each rectangle. Now notice that the width of each rectangle is the same. So that's going to stay fixed for every single rectangle we have. Now the only thing that's going to change is the height of these rectangles, or the length. And that the height of these rectangles is based on the x value. Right, so if you take a look at this first rectangle, the height is at f of 0.5. Right, that's the height of this rectangle. So over here, the height of this rectangle is f of 1. And the height of this one is f of 1.5. So let's go ahead and look at our first rectangle. Alright, it's x1 because it's our first x1, our first x point, and our first x value. Wow. Times 0.5, which is the width of this rectangle. And if I evaluate f of 0.5 times the width of the rectangle, I get 0.625. I'm going to write that down right here. So if I move on to the second rectangle, which now notice that the height of this rectangle is based on evaluating the function at 1, so this is f of 1. And if I multiply that by the width of the rectangle, which is 0.5, we get 1. Moving on to the third rectangle, right, which is f of 1.5, which is right here. that's the height of this rectangle, times the width of the rectangle, and we're going to get 1.625. And finally, moving on to the fourth rectangle, right, you're going to find f of 2. That's going to find the height of this rectangle, multiply it by the width, and that finds the area of this rectangle, which is 2.5. If I were to add up all of those values, we get 5.75, which is what we had a couple examples ago. Now, this method we just used is called right-hand endpoints. Notice that each single rectangle, each individual rectangle, the height is based on evaluating the right-hand endpoint in that little subinterval. So we would call this a subinterval right here. And we have a left-hand endpoint, which is 0, and a right-hand endpoint, which is 0.5. So notice that in each one of these, it's the right-hand endpoint that determines the height of the rectangle. So that also means we have left-hand endpoints as well. Notice that each one of these rectangles now, the height of the rectangle is now based off of the left-hand endpoint. So the height of this rectangle is f of 0. The height of this rectangle is f of 0.5, and so on. And if we were to find the area of these, we'd get 3.75. Now remember, I told you the true area was 4.6 repeating. So this is actually an underestimate. But that makes sense because notice that every single rectangle underestimates the area a little bit. So you can see that we have this extra area that we haven't added up. Now if you put them side by side, you can see how each one is constructed. Left-hand endpoints. We use the left-hand endpoint in each subinterval to determine the height of the rectangle. And again, over here at the right-hand endpoints, we would use the right-hand endpoint. I think it's pretty clear on how this works. So the steps to estimate the area using right-hand endpoints is as follows. Find the width of each rectangle. Now what you're going to do is you're going to take the length from A to B, so basically the length of the total interval, and divide that by the number of rectangles. Then next, we're going to find xi. We need to actually know the endpoints, those x values, in order to determine the height. So this is the formula for it. A is your starting point, so for us A was 0, and then I just stands for whichever x value you're at. Notice that for right-hand endpoints, I starts at 1 and goes up to n. Left-hand endpoints, I starts at 0 and goes up to n minus 1. Finding the area of each rectangle, we've already seen the formula for that, which is this. And if you were to take a look at an individual rectangle here, you can see the width of the rectangle is delta x, and the height is found by evaluating the right-hand endpoint, which is f of xi. So in this case, it's f of 1.5 for this particular example. Finally, you would add up all the rectangles, and that would be it. Which is exactly what we did in this example. We had 4 rectangles. We found all my xi's, which I actually did prior to doing this example on the video, but we found them 0.5, 1, 1.5, and 2. If you were to use this example, or this formula, you will get those values.